children, we'll start with redox reactions. Same lesson. So you have to complete redox reactions, isn't it? I told you this chapter is a very important chapter. Why? Because we have this chapter in 12th standard in electrochemistry. We have to study redox reactions in electrochemistry when you come to 12th standard. And from redox reactions you can expect 3 to 4 questions in your NEET IIT exams also. In JEE main and advanced last year, 5 questions have been asked from this redox reaction. So ensure that you are getting thorough with redox reactions. Okay. So we will recap what are all the concepts that we have studied in the previous class. So I told you what is redox reaction. Redox reaction is a reaction in which both the oxidation as well as the redox reactions occurs simultaneously in a single reaction. So there will be a single reaction, the reactants will react and we will be getting a product. So reactants will react and we will be getting a product. The reactions which is going to react with one another will follow both the oxidation as well as the reduction mechanism. So oxidation and the reduction occurs simultaneously in the same reaction. Then we are calling it as a redox mechanism or the redox reaction. So redox mechanism, redox reaction is all the industrial process, pharmaceutical industries, and similarly the crackers. We are burning the crackers, isn't it? The burning of crackers, combustion of propellants. So the propellants for launching the satellites, for the rockets into the space, say the combustion of propellants. So all these things follows the phenomenon of the redox reaction. So redox reaction plays a significant role. What is a redox reaction? I have told you oxidation as well as the reduction should take place at the same time. Oxidation and the reduction reaction will be taking place at the same time. Oxidation and the reduction reaction will be taking place at the same time. What are the definitions I told you? I told you the oxidation is nothing but it is a loss of electron and the reduction is a gain of electron. Gain of electron. Then second one, in case of oxidation, oxidation is the addition of oxygen or the electronegative atom, or otherwise the addition of electronegative atom. What is reduction? Reduction is the removal of, reduction is what? The removal of oxygen or otherwise the electronegative atom. Here, oxidation is the removal of hydrogen or the electropositive atom, isn't it? Atom. Whereas in case of reduction, we can say it as addition of hydrogen or the electropositive atom, This is for the reduction and this is for oxidation. So in the previous class I have explained you about the oxidation, addition of oxygen and electronegative atom and removal of hydrogen and electropositive atom, and various examples I have given you. So today we have to study about the loss of electrons and gain of electrons. Loss of electrons and gain of electrons. In the previous class I have explained about the addition of electronegative atom or the addition of oxygen. For that I have given you various examples, and similarly removal of oxygen and removal of electronegative atom also I have given you various examples. Similarly here the removal of hydrogen and electropositive atom also I have given you various examples, and addition of hydrogen and electropositive atom also I have given you various examples, isn't it? And today we are going to see about the loss of electrons and gain of electrons. We will see now. So one more definition for oxidation and the reduction, that is redox reaction. Okay? Say for example, first example, let me take 2Na plus Cl2, which gives rise to the formation of 2NaCl, isn't it? So the product is sodium chloride, which is called as an ionic product. Why it is called as an ionic product? Because it has both the cation as well as it has an anion. What is this cation? Positively charged. What is anion? Which is negatively charged. So positively charged here is sodium, negatively charged here is chlorine, isn't it? Now here you see, in case of sodium, sodium 2Na. This is the solid metal which lost 2 electrons, and as a result it becomes Na plus, isn't it? So there what happened? Loss of electrons has taken place. Now we will write the reaction down. That is 2Na becomes 2Na plus 2 electrons. Can you understand what I have written? So this is what? Sodium metal. This is what? Sodium metal. This sodium metal lost 2 electrons, and as a result it becomes cation. That is sodium becomes sodium ion. And similarly we take this chlorine. So this chlorine takes away 2 electrons. That means what? It gained 2 electrons. Here we can say it as what? Gain of 2 electrons. Gain of 2 electrons. So it gains 2 electrons, and as a result it becomes 2Cl minus. So now when this chlorine molecule or chlorine atom is in a molecular state, attains 2 electrons, gains those 2 electrons, it becomes anion, chlorine ion. It becomes what? Chlorine ion. Now we'll solve both the equations. When I solve both the equations, this 2E and this 2E will be getting cancelled. So what we'll be getting? That is 2Na plus Cl2 gives 2Na plus 2Cl minus. So this is on the reactant side and this is on the product side. Same reaction criteria. Now here what happens? This chlorine gained 2 electrons. Here sodium lost 2 electrons. So since the sodium here what happens? Sodium it lost 2 electrons. Suppose product side 2 electrons on this side. Sodium metal to sodium ion. So it lost 2 electrons. So we can call it as loss of electrons. Since the electrons are lost, the reaction is called as oxidation reaction. The reaction is called as what? Oxidation reaction. Now this sodium is considered to be an oxidized atom. It has oxidized. It has what? Oxidized. Isn't it? Now sodium has what? Oxidized. So sodium is an oxidized atom. So there the loss of electrons has taken place. So sodium has what? Oxidized. Now so now the next one we will go for this chlorine. What's the condition? What is happening in this chlorine? Here in chlorine, the gain of electron has taken place. The gain of electron has taken place. So since the electrons has got gain, we call it as reduction. We call it as what? We call it as reduction. So gain of electron, so we call it as reduction. So therefore this chlorine is reduced. The chlorine we call it as reduced. Why it is reduced? Because it has taken the electron. Why sodium is oxidized? Because it has given 2 electrons. So loss of 2 electrons here, gain of 2 electrons has taken place. So oxidation, loss of electrons. Oxidation, loss of electrons. Reduction, gain of electrons. So chlorine now it is reduced. Sodium is oxidized. Now we have to keep one thing in mind, that is this sodium makes the chlorine to get reduced. Correct? So sodium makes this chlorine to reduce. In a chlorine can reduce. What is reduction? Reduction na electron gain panadhu. So chlorine has gained 2 electrons. So every chlorine electron connected by gaining the 2 electrons from the sodium. So sodium is in a position of giving away the electrons. The sodium makes the chlorine to get reduced. So therefore the sodium is called as the reducing agent. Sodium is called as what? Terms you keep it in mind carefully. So what is reducing agent? Sodium is a reducing agent. Why? Because the sodium makes the chlorine to get reduced. How it makes the chlorine to get reduced? By gaining the electrons. By gaining the electrons from the sodium. Vice versa. What's happening in this chlorine? The chlorine makes the sodium to get oxidized. The chlorine makes the sodium to get oxidized by creating the deficient site of electrons in its outer shell, and therefore it accepts the electrons from the sodium. So chlorine makes the sodium to get oxidized. So therefore this chlorine we can call it as an oxidizing. We call it as oxidizing agent. So this is a reducing agent, and this we can call it as the oxidizing agent. So reducing agent, the other one is oxidizing agent. Understood what I have written for this reaction? Sodium with chlorine and sodium chloride, and it is an ionic product. The question exam sometimes they will give you the reaction and they will ask you to find out whether this reaction is a redox reaction or what. So reaction product, when you see the product only you can come to know this is a redox reaction, because whenever the ionic product is going to be formed, from there we can confirm that whenever the ionic product is going to be formed, ionic product form on the product side, from that we can confirm that it is a redox reaction. That is a redox reaction. Then oxidation, we have to write this step. For the reduction we have to write this step. Oxidation, the loss of electrons, reduction, the gain of electrons. When loss of electrons, oxidation, then the sodium is oxidized, chlorine has got reduced. Now this sodium makes the chlorine to get reduced. So therefore this sodium is called as reducing agent. Now this chlorine makes the sodium to get oxidized. So therefore the chlorine is called as oxidizing agent. So reducing agent and oxidizing agent. Now one more reaction we'll go for one more reaction, that is in your textbook they have given, book exercise they have given, that is sodium reacts with hydrogen, it gives rise to the formation of sodium hydride. Say what is the reaction? The reaction is sodium. Second example, that is sodium reacts with hydrogen, giving rise to the formation of sodium hydride. Sodium reacts with the hydrogen, giving rise to the formation of sodium hydride. So again now this is solid, which is a gas, and this is also a gas. Okay, now we have to find out, check whether the given reaction is a redox. It's a redox reaction. This is the question. This is the question. What is the question? So what's happening? So sodium combines with hydrogen, giving rise to the formation of sodium hydride. Check whether the given reaction is a redox reaction. So by seeing the product itself, we can identify that it is a redox reaction. Why? Because the product formed is what? It is an ionic product. From the product we can identify it is an ionic product. It has an ionic product. So whenever the ionic product is taking form, we can confirm that it is a redox mechanism or redox reaction has taken place. Now you see the reaction. Once again, we write down the reaction, that is 2Na plus H2 becomes 2NaH, sodium hydride. This is sodium hydride, this is sodium, this is hydrogen, so it forms what? Sodium hydride. Now what is the condition here? First we will go for oxidation. We will take this sodium, that is 2Na becomes 2Na plus 2 electrons. First condition. So here what has happened? 2 electrons has been lost. So here the loss of electrons has taken place. So when there is a loss of electron, that indicates the reaction is what? The reaction is oxidation reaction. Whenever there is a loss of electron, it is an oxidation reaction. go to this hydrogen. Now this hydrogen will take away the 2 electrons from the sodium, and as a result it becomes 2H minus. So now here what has happened? Gain of electron has taken place. Now the gain of electrons. So when there is a gain of electron, that indicates it is a reduction reaction. It is what? It is a reduction reaction. Now you solve both the equations. Solve both the equations. This is equation number 1 and this is equation number 2. Solve both the equations. So what will happen now? This 2 electrons on the product side, 2 electrons on the reactant side will get rolled off. Remember what they have? That is 2Na plus H2, because no other chemical substance or atoms or electrons are present. So 2Na plus H2 then gives what we have 2Na plus and 2H minus. H minus. So we got question side 2Na plus H minus on the question side. So we got 2Na plus and H minus. So our Na becomes Na plus. For reaction Na becomes Na plus. Na becomes Na plus. Now what has happened? Loss of electron has taken place. So when loss of electron has taken place, that shows it is an oxidation reaction here. So oxidation reaction. Here what has happened? This hydrogen have gained 2 electrons. So gain of electrons. That means what we call it as reduction. Then next is, from this reaction, sodium reacted with the hydrogen is a reaction, product is sodium hydride. So from this reaction you have to tell me which is oxidizing agent and which is reducing agent. Now which is oxidizing agent, you have to identify which is an oxidizing agent and which is a reducing agent. Which is oxidizing agent? Now this sodium makes this hydrogen to get reduced. Sodium makes this hydrogen to get reduced. So therefore the sodium is called as a reducing agent, because sodium is reducing this hydrogen. So therefore reducing agent here is sodium. Reducing agent here is sodium. Now this hydrogen makes the sodium to get oxidized. So therefore this hydrogen is considered to be the oxidizing agent. Is considered to be what? Is considered to be an oxidizing agent. So reducing agent is sodium. Here sodium is a reducing agent. So because this sodium has undergone oxidation, loss of electrons, giving away the 2 electrons. So therefore hydrogen gains those 2 electrons. That is why sodium is giving those 2 electrons. So hydrogen is reducing this sodium. So therefore hydrogen is called sodium is giving away the 2 electrons and this hydrogen is taking away the 2 electrons. So therefore hydrogen is reducing this sodium. So therefore sodium is considered to be the reducing agent. When the sodium hydrogen becomes an oxidizing agent. Why it is considered to be oxidizing agent? Because it oxidizes the sodium. So therefore hydrogen becomes oxidizing agent. Apparently vice versa. Oxidized substance, oxidation, the sodium is doing the oxidation. So therefore it will be the reducing agent. Hydrogen reduction gain of electrons. So therefore it is an oxidizing agent. So reducing agent and oxidizing agents in terms of electron transfer I have told you. Now we have to go for the next topic. What is the next topic we have is competitive electron transfer reactions. What is the next one? The next one which we have is competitive electron transfer reactions based on competitive electron transfer. We will see now. Reactions based on competitive electron transfer. Now This is a very important concept. The same concept we will be studying in 12th standard galvanic cell construction standard of dry cell, Daniel cell, galvanic cells. We will be studying this topic. So now we'll take zinc. The zinc strip, a zinc metal. Now this zinc strip is getting immersed in the copper nitrate solution. This is a copper nitrate solution. Now this copper nitrate tends to be blue in color. Okay, and now this is a solid and this is a liquid. Straight there, copper nitrate solution on iron. Now what happens is here this zinc displaces copper. So our zinc nitrate plus this copper, which is solid, again which is liquid. Now this blue color of the copper nitrate becomes colorless. It becomes what? Colorless. Now you see the zinc, which is a solid, metallic solid, the zinc will be having its oxidation state 0. Now for this copper, ionic state 2 plus, salt color clear. So here it is 2 minus. This is no problem. Here zinc it is 2 plus, and here it is 2 minus. No problem. Copper now it is in a solid state. So metallic solid oxidation state tends to be 0. This is the overall reaction. Now if the overall reaction I am writing it down, so then better you can understand. That is zinc plus copper nitrate, that is twice, it gives rise to the formation of, that is zinc nitrate, which is twice plus the metallic copper. What is the oxidation state I have written? For zinc, the oxidation state will be 0, metallic. Whereas for the copper, it is 2 plus. Nitrate, no problem, 2 minus. Zinc, it is 2 plus. Again, it is 0. Now, here the zinc metal becomes Zn2 plus. Clear? 0 oxidation state. Zinc or metal or solid metal gives away 2 electrons. So therefore it becomes Zn2 plus. What is the condition here? Loss of electron has taken place. Loss of electrons. So why loss of electrons? Zinc oxidation state is 0. This zinc has given away the 2 electrons. Loss of electrons. So therefore it becomes Zn2 plus. What happens to this copper? Here in case of copper, it takes away the 2 electrons from the zinc. But Cu2 plus becomes Cu. So it takes away the 2 electrons. So gain of electron. So what has happened? Gain of electrons. Here loss of electrons, here gain of electrons. So but we'll write down the reaction separately. That is Zn. Zn becomes Zn2 plus 2 electrons, because here what has happened? Loss of electron has taken place. Loss of electron. So therefore we can call it as oxidation reaction. And this zinc acts as a reducing agent. The zinc acts as reducing agent. First condition. Now coming to this copper. Copper, what has happened to this copper? This copper, that is Cu2 plus it takes away those 2 electrons, and as a result it becomes copper metal. So here gain of electron has taken place. Here what happened? The gain of electrons has taken place. Gain of electron. So when there is a gain of electron, that shows there is a reduction reaction has taken place. Reduction reaction. So therefore this copper is considered to be an oxidizing agent. It is considered to be what? An oxidizing agent. So what is the overall reaction now? The overall reaction will be these 2 electrons on the product side and reactant side, the 2 electrons on the product side will be ruled off. And what is the overall product reactant and the product? Zn plus Cu2 plus becomes Zn2 plus Cu. Can you understand? This is the overall reaction. So what we are confirming from this reaction, I hope you can understand. Reactions based on cooperative transfer. So I have taken the zinc strip and the zinc strip is immersed into that of a copper nitrate solution, which is blue in color. After the zinc copper nitrate immerse the solution slowly changes to colorless. That means I have got zinc nitrate. அப்ப the zinc nitrate carbon என்னது the zinc displaces this copper. That means what? Zinc can readily give away or donate the 2 electrons and compared to that of a copper. Or otherwise we can say zinc is highly reactive, so which has displaced this copper and therefore it becomes colorless. Now in this reaction we say that it is a redox mechanism because oxidation has taken place, reduction has taken place, loss of electron has taken place, and similarly gain of electron has also taken place here. Okay, so now from this reaction so now I am going to reverse the reaction. What is that reversing reaction? Now to the zinc nitrate to this is zinc nitrate solution. To the zinc nitrate solution I am going to immerse copper strip or otherwise copper rod. What is the reaction? What is the chemical change? So here no reaction occurs. Why no reaction occurs? Why? Because when you take out this zinc is highly reactive. That means what? It can readily loses 2 electrons than compared to the copper. Can you understand? Now if we go to the second example, what is the second example actually? We'll take copper with that of silver. We'll take second example. Now this copper reacts with silver and as a result it becomes 2Ag. One example. Copper reacts with that of a silver, giving rise to the formation of Cu plus and 2Ag. That means what? Here what has happened? So copper reacts with what? Copper reacts with that of 2Ag. So as a result it becomes what? Cu and 2Ag. So in the balance formula this becomes 2Ag and this becomes 2Cu plus. Now we will go for the reaction. Here this copper becomes Cu plus. That means what? Here the loss of electron has taken place. This Ag has gained the electrons. So here what has happened? Gain of electrons. Shall we write the reaction separately now? This 2Cu becomes 2Cu plus 2 electrons. Here again 2Ag plus 2 electrons, it becomes 2Ag. So again loss of electron, here gain of electrons has taken place. So that means what? When you compare with the zinc is highly reactive than compared to that of copper. Now here in this case the copper is highly reactive than that of the silver, that is Ag. Okay, this is the second example. So this type of order, what is that order? This type of order this type of competitive electron transfer, competitive electron transfer reactions helps in framing reactivity series, or otherwise we can call it as electrochemical series. Construction of the electrochemical series. Okay, so what is it? Reactivity series or electrochemical series? We'll see now. Reactivity series or the electrochemical series. Say for example, so let me write the electrochemical series. Yeah. So that is this is a song. So this is what? Sodium. The order I am writing. This is sodium, and this is barium, and this is what we have, calcium, and then what we have is sodium. Then merc, al, sun, cur, magnesium, aluminium, zinc, chromium. How to memorize? Kaba, Kana, merc, sun, cur. Okay, this is how we studied in our college days. Okay, sun, cur, then Fe should come. Yeah, that is Phi, Buck, Phi, Sun, Buck, then High, Ku, Hug, Out. This is the reactivity series. So reactivity series shall get sodium, potassium, potassium, barium, calcium, sodium, magnesium, aluminium, zinc, chromium. Then here iron, tin, lead, hydrogen. See, hydrogen is the only non-metal. Hydrogen is the only non-metal in the series, in the metallic series. So sometimes it acts as a metal as well as a non-metal. So that is why the periodic table we can separate it as to be noted. Then what we have? Copper, mercury, then silver, gold, and then platinum. So first zinc. Next to the zinc, what we have is copper. Next to the copper, what we have is the silver. Now you check in the metallic series. Why the first one? First, which is coming? First is zinc comes first. Next to the zinc, what is coming? Copper comes next. Next to the copper, the silver. So the metallic series. Why? What this metallic series gives you, or reactivity series will gives you the strength of the metal. So the reactivity series. So shall I write here? The reactivity series gives or explains the strength of the strength of metal. It explains the strength of the metal. What is meant by strength of the metal? Strength of the metal explains the loss of electrons, giving away of the electrons. So that is why, based on the reactivity series, we can construct the cells or the batteries. We can construct the cells or the batteries. Say for example, you can take galvanic cell. Say again, let me write the galvanic cell. Galvanic cell we will be using electrodes. You will be studying first standard. Just like that I am telling you, electrodes and electrolytic solution. So based on the electrodes and based on the electrolytic solution, there will be the potential gradient. What is the potential gradient is called EMF. So that is electromotive force. So the difference between the potential gradient or the electromotive force between the electrodes and the electrolytic solution or the metals that is being taken, the amount of electricity will be getting generated. So every amount of electricity is getting generated. Based on that, we can predict the validity of this cell or the batteries. Can you understand? அப்ப நம்ம electrodes சரி electrolytic solution what will be using the metals. எங்க இருக்கக்கூடிய metals of the electrochemical series or on the reactivity series. இந்த reactivity series or electrochemical series எதை பேஸ் பண்ணி how on what basis we have framed? It has been framed based on the redox reaction, based on the oxidation and the reduction potential, oxidative potential and reduction potential. அதை பேஸ் பண்ணி நம்ம இங்க கொண்டு வந்திருக்கோம். இங்க one more point I forgot to tell you. See this reaction, one we are calling as oxidation, the other one is called as reduction. So overall reaction I have written. So this oxidation is called as oxidative off-cell. This is one off-cell reaction and this is the second off-cell reaction. So oxidative off-cell, reduction off-cell reaction. When these two off-cells are combined and it gives rise to the formation of a complete oxidation plus reduction, giving rise to the formation of the redox reaction. Giving rise to the formation of the redox reaction. Okay, so we are studying about the redox reactions. So for redox reactions, now here redox reaction, what is the definition I have told you. அதுக்கப்புறமா oxidation என்ன நிறைய points or 3 points we have studied. Loss of electrons, அதே மாதிரி addition of oxygen on the electronegative atom, loss of hydrogen on the electropositive atom. So the loss of hydrogen, loss of electropositive atom, gain of oxygen or otherwise gain of electronegative atom. In a previous class I have given you various examples and I have told you. Based on the electron transfer, that is gain of electrons, loss of oxidation is a loss of electrons. So the loss of electrons, I have given you various examples: formation of sodium chloride, formation of sodium hydrate, and similarly competitive electron transfer zinc with the copper nitrate, and similarly with that of silver nitrate silver with that of a copper. I have given you the examples. So reduction, what we are telling, gain of electrons or the removal of oxygen of the electronegative atom, addition of hydrogen or otherwise addition of electropositive atom. For that I have given you lots of examples in the previous classes. Angiyo loss of electron eppadi varudhu, why gain of electron and loss of electron should take place, and I told you this loss of electron and the gain of electrons based panni we can create for a metal electrochemical series. In the electrochemical series based panni we can construct the cells of the batteries. So the efficiency of the battery or electromotive force, another gradient appdin solranga, electrochemical gradient we are telling, isn't it? Potential gradient, the potential gradient of those two off cells, illa potential gradient of between the two electrodes or electrodes and the electrolytic solution will determine the amount of electricity that is being generated. So amount of electricity generated will determine the efficiency of the cell or the battery. Appo efficiency of the cell and the battery edha base panni nama kondu varom, the electrons donate பண்ணக்கூடிய tendency. Electron how effectively can give away the electrons engrada electrochemical series நம்ம கொண்டு வரோம். இந்த electrochemical series இந்த elements எல்லாம் நான் frame பண்றதுக்கு I have to go for the redox reaction. Redox reaction ல இருக்கக்கூடிய electron transfer reaction or competitive electron transfer reactions தான் I have to come. Okay, so till this, see to that you are studying and you are taking down in the notebook, and in the next class we will see what is meant by oxidation number and how to calculate the oxidation number and the different types of redox reactions, how to balance the redox reactions. Okay, so till this I have told you what is meant by redox reaction. So fulla irukkudiya redox reaction enna appadina solliten, the sodium hydride veche irukkudiya reactions also they have asked in your IET examination, NEET examination last year. So in your book also they have given that reaction, that is why I have written on the board. So take down, see to that you are studying. Okay, thank you.